any of our plants, and any of you who use water, like the Coca-Cola man, you might want to visit a water treatment plant. Our pumps are huge because we have to move so much water. We have installed variable frequency drives on our pumps, which permit us to match the pumping rate to our demands over time. Demands, obviously, in a day aren't the same. You can watch demands in the morning and the evening change. In the old pumps, the rate was consistent. We've significantly reduced our usage of energy as well as the cost for that energy by installing variable frequency drives on our pumps. We've also installed, in terms of lighting, in our plants, and a treatment plant is a huge facility, much larger than any of our offices, but in both offices and treatment plants, we've installed high-efficiency fluorescent lighting. I'm not sure if we have any of those Lutron dimmers, but it might be something to look at. But we do have, I call them motion sensors. Our folks call them occupancy sensors in our offices and treatment plants. But I know that even if they're supposed to, if you're in the building, in the facility, the light should be on. If you're not in the building, the light should be off. But I know that even if you're in the building, sometimes the lights go off. If you spend 5 minutes, it seems, thinking about a problem, and you sit still at your desk or your computer or elsewhere where you might be thinking, the lights will go off. So it's really not about occupancy, but it's about movement. But certainly we've reduced our power bills over time, our lighting bills. In terms of operations, we have employed various forms of alternative energy, and I'll talk about those in a minute. But in the distribution system, I mentioned the pipes, they're underground. So you might imagine 10,000 miles of pipe, and it's not one continuous pipe. Pipes are connected, we have valves in the pipes, we have leaks in the pipes. Some of our pipes are more than 100 years old, and when your pipes are underground, those leaks don't always surface. So we focused on a continuous replacement of our pipes. We're at about 1%. Pipes last about 100 years. So that's a pretty good replacement rate. We've also used technology to detect leaks. You've got to get the leak before it necessarily surfaces because most of the leaks don't show up above ground. If we're able to reduce the leaks, reduce water, that means we reduce energy to produce the distribution of that water, and at the same time we also reduce chemicals. In terms of alternative power sources, our company's mission is continuous improvement. So day in and day out, we're looking at what we do, how we can do it better. It seems like water has been produced and distributed, treated about the same way for a long period of time. But day in and day out, we focus on how we can do it differently, how we can do it better. One of the focuses is how we can reduce energy and still provide safe and reliable water and wastewater service. It wouldn't help us if we reduced energy, we just notch back the pumps, right? And when you're in the shower, you put soap in your hair, you don't have enough pressure to get the soap out. So there's ways that we could reduce energy, but at the same time, we're regulated by the Public Utility Commission, and we have certain obligations in terms of reliability and service. So we have to maintain a delicate balance between reducing the resource use, reducing our expenses, but at the same time meeting our service obligations. One of our plants that's shown on this slide in Yardley, which is outside of Philadelphia, it's a 6 million gallon a day plant, so relatively small as our plants go, serves about 12,000 customers. We've been using wind power at that plant since 2005. We originally enrolled in PECO's wind energy program, and now we're buying wind power from Suez Energy. That green power is equivalent to planting 119,000 trees. We also can equate it to a reduction in miles driven. Think about it, if you were able to reduce the number of miles driven by 1.5 million miles driven, that's what using wind power in this small plant accounts for. We were given a Green Power Award by Citizens for Pennsylvania's Future. I know them as Penn's Future a number of years ago. So 2005, we started using wind power in our Yardley facility. Up in the Northeast, we have a number of surface water treatment plants, one of which is Nesbitt. Nesbitt is a little bit larger plant than Yardley, double the size, 12 million gallons a day, serves about 26,000 customers. When we constructed this plant in 1988, we designed and installed a hydroelectric generator. So 1988, pretty far back from where we are now, but there was a surge in the 80s in terms of solar, wind, hydroelectric. We put a generator in this plant, 150 kilowatt generator. This generator provides all the power that's needed for this plant, and sometimes more. And when it provides more power than the plant needs, then we're able to sell that power back to our energy supplier, which is PPL. When the when the generator's down for maintenance, obviously we're back on the grid. We're back buying power, regular power from PPL. The difference in power cost is significant. $2,000 a month when the generator's running, $7,000 when it's not running. So a large savings for the company and also for our customers. In the Northwest, 2010, 2011, we installed a microturbine. The microturbine at our Oneida Water Treatment Facility in Butler County uses energy from water that moves from our reservoir into our treatment plant. Much smaller, 20 kilowatt generator, but reduces our carbon footprint, and it also gives us the opportunity to ask for and secure a grant from the Pennsylvania Energy Finance Authority, from PETA. Didn't fully fund the micro turbine, but partially generated it. Gave us another opportunity, another way to reduce those energy costs and reduce our resource use. Finally, our most recent focus, a little bit different, is a partnership for a pilot project at our Shire Oaks pumping station with Enbala. Enbala has technology that permits the grid, the power grid, which is PJM, to talk with our pumping station, and that's real time. So the Enbala's balance grid or grid balancing product gives the power grid the opportunity to use the flexibility in the water system's use of power. We can store water and we can pump at different times because we have tanks, numerous tanks to store the water. So this grid balance product permits reliable power balancing to focus on pumping. We can use our power when uses of power in the rest of the grid are low, and then increase it or decrease it when power use on the grid is much lower. So it provides some flexibility for the grid and some reliability, as well as providing us with a source of revenue and a decrease in expenses because we're paid for this product. Just a pilot project at this point, but we're looking at rolling it out in other areas of our facilities. When I mentioned earlier, we focus on continuous improvement. We focus on continuous improvement in all of our operations. But as we focus on continuous improvement to reduce our resource use, reduce our energy use, it reduces power expense. And when we reduce power expense, that gives us additional cash flow to focus on replacement of infrastructure, which clearly, whether you think 36.5 billion or you think 5 billion over the next 20 years, we need cash flow to be focused on capital. And one way that we can reduce our operating expenses is to focus on power use and reduction of power use. By doing that, we're still able to treat and deliver water through our packaging, our pipes, directly to a customer's home, still for about 1 penny a gallon. I appreciate your time. Thank you very much.